Hello students. Now we'll start with IR spectroscopy, but second part, right? In last part, we have learned what is the principle of IR spectrum, then how IR spectroscopy is distinguished with other spectroscopy techniques like microwave, NMR, UV, visible, or the radio frequency like that. Okay. Then we have learned the principle as well as the modes of vibrations. How the IR spectroscopy is called as vibrational spectroscopy. Then how to calculate the modes of vibrations with some examples, right? And the what are the vibrations are there? They are stretching, asymmetric stretching or bending like that. Okay. So hope you remember that part. Now we'll start why this frequency is important, how is related with different functional groups, okay, and what is the formula and how to calculate it. That we will learn. Myself, Dr. Sharad Pasli, Department of Chemistry from Thakur College of Science and Commerce. Okay, so let's begin. See, this is the Hooke's law. This is called as Hooke's law. HOOKS, right? So this is the called as wave number is equal to 1 upon 2 pi c under root k upon mu. Here pi, you know the pi value, then c is the speed of light, then k is the constant, and mu is the uh, is like this, means m1 m2 is called as reduced mass, right? So m1 m2 divided by m1 plus m2. This is the mu formula. Okay. So what is m1 means? Mass of one atom, mass of another atom, like that. Okay. Then the value we used to take for speed of light is velocity of light is 3 into 10 raised to 10. Then this is the k is the constant, the value known, and then depend on the mass of depend on the atoms and the reduced mass, like that. Okay, so this is all about the formula which is Hooke's law, and based on this Hooke's law we can calculate the wave numbers. Okay. In force constant also is different for single bond, double bond, and triple bond. Actually, that is in proportions. So here we have given the what is the force constant for single bond and triple bond as well. Okay. So for example, if we have put the value of carbon single bond carbon stretching frequency or wave number, then it will comes around 1200. The value it will come for carbon triple bond carbon is 2150. These are the approximate value. By calculation, it will come around minus plus 5. Okay, like that. It means that for single bond, value is less than double bond, than triple bond. Okay, so it will increase. Again, depend on the reduced mass, again the value is changing. If there is a difference, huge difference between two atoms, the reduced mass, the value is too high. High means how much? See here the difference. In bromine, it will very less than chlorine, then oxygen, then carbon, and then hydrogen. So when there is a stretching frequency of carbon and hydrogen, then the value is around 3000. Okay, and these all value are in centimeter inverse, and we can call it as the wave numbers. Okay, so how it looks actually IR spectrum. See here IR spectrum in y-axis there is a percentage transmittance, and in x-axis you can see the vibrational frequencies. Okay, but we have written this frequency in wave number. Understand? Okay, so these are the peaks how to read these peaks and other things, that also we will learn. Okay. So here I have put one box which is in red color up to 1500, means this region is fingerprint region. Okay. And after that, this is the functional group region. So we have to more focus after 1500. So from 1500 to 4000 max. Okay, this is our core region where we have to concentrate. Why we have to concentrate? Because these functional group peaks, they are very sharp or broad, strong, and like that. Okay, so we can distinguish these peaks for which functional groups. Okay, so we'll see few examples, then you will have more idea. Okay. So depend on shape as well, right? See here we have given the example. Suppose this type of peak, this is very broad peak, and this is comes around 3500. So it must be oxygen, hydrogen stretching. Okay, OH stretching we can say. So this stretching frequency, this is too high, and it will show the very broad spectrum rather than sharp. Because this why broad spectra is there, I have given here the uh, explanation is due to the hydrogen bonding or presence of water molecules only, you will find the broad spectrum. Otherwise, all peaks are either sharp or medium or weak, like that. Okay, so these are the some uh, explanation for why broad, sharp, and like that. Okay. Then what are the factors affecting on the these frequencies? First factor is if basic is bending frequency is smaller than the stretching frequency, right? For bending is smaller, and the stretching it will require more frequency. Then reduced mass of atom is again inversely proportional to the frequency. Okay, this is the another criteria. Then more vibrational frequency means more force constant that we have discussed in last slide, right? Single bond, double bond, and triple bond like that. Then electronic effect, again, if conjugation or resonance is there, obviously their vibrational frequency is more. Then if hydrogen bonding is there, then less vibrational frequency. Okay. Then multiplicity of bond, number of bonds is increase, vibrational frequency will increasing. Means increasing frequency, increasing bond strength. Right? This is the criteria. Here also I have given few examples. Then what about nature of hybridization? Yes. If in hybridization S, P character or D character based on, if percentage of S character is increased, means bond strength is increasing. Okay. Bond strength increasing, bond length decreasing. Right. But frequency is also increasing. Understand? So percent, see here. So when percentage of S character increase, bond strength also increase. Frequency also increase. Only bond length is decreasing. Okay. Yes. Hope you understand. Then see, these are the types of peaks how we can interpret or analyze which functional group it is. Okay. So randomly, I have given only few examples. Okay. So less than 1500 we used to call fingerprint region, and that region is not that much useful. Okay. So we have to focus after 1500. So actually it will start from carbon double bond oxygen, means ketone, aldehyde, acid, ester. So we can have the stretching frequencies around 1650 to 1800. This is the one reason it will come, sir. Then the triple bond, carbon triple bond carbon or carbon triple bond nitrogen, it will comes around this region, 2100 around. Okay. Then the stretching frequency of carbon single bond hydrogen. Again, that stretching is with aliphatic or with aromatic, it will come around 3000. If aromatic frequency is there, CH stretching is there, then more than 3000. And aliphatic is there, slightly less than the 3000. Okay, these are the few hints. Then what about NH and OH? Okay, so NH stretching will come around 3300 and OH will go more than 3300, is nearby 3400 is OH frequency. Okay, so these are the basic, we can say the not rule, mm, but we can say, okay, these are the basic information about how to identify the functional groups. Okay, these are the zones. Yes, the good word is zone. Okay, see the zone 1, 2, 3, 4. So first zone is more than 2700 up to 3600. Here you will find only the stretching frequency of CH, NH, and OH. So obviously OH is more, then NH, and then CH. Understand? Okay. So first OH, higher frequency, then NH, and then CH. Done? Okay. Then 2700 to up to 1900 is triple bond region, either carbon double bond nitrogen or carbon triple bond carbon. Again, in the same region, you will find the azide also, N3. Also, you can find in this region, zone 2. Then zone 3, which is carbonyl or double bond region. Okay. All double bond containing stretching frequency you will find in this zone, right? And the last but not fingerprint, that reason is carbon single bond oxygen and carbon single bond carbon. It will come around 1500. Okay. Yes. So here are the few examples. Then OH, then NH. NH will have again the different two peaks are there. For the primary amine, there are two signals, and the secondary amines, there are only one signals because primary amine will have two hydrogens, secondary amine will have single hydrogen. So tertiary amine will not give any peak in the IR spectrum. Okay. The same for CH stretching, as I have mentioned. Double bond CH means aromatic frequency. There you can find more than 3000 and single bond less than 3000. Here you can see it. Okay. In zone 2, that is triple bond region, I have already mentioned, you can see it will show the very sharp peak and very informative. What about zone 3, carbonyl region? Again, here you can find out stretching peak is different for ketone, aldehyde, carboxylic acid, ester, like that. Okay. So these are the peaks and how it will looks like. You can pause it and you can see what type of peaks are there. You can make short notes as well. Okay. Then the same with after carbon double bond oxygen, carbon double bond carbon, right? It will come around 1600. Okay. Uh, it will looks like this. So what are the examples that I have written in benzene ring like that? Okay. And then the stretching frequency, but less than 1500, uh, especially for ether, carbon single bond oxygen, you will find it in around 1100. Okay, so these are the characteristic peak. So see here, this is the one of the example how you can detect the compound from higher spectrum. So again here we will focus after 1500. So only this region. So you can see here, this is the broad spectrum, broad peak you can see. It means that there is either OH or water molecule is there. Okay, so this peak is belongs to, it will comes around 3400. Then this sharp peak is there for CH stretching, but which is less than 3000. Okay, see the wave number will starts from 4000 and it will come up to 500. So remember the value is decreasing. Ah, ah. So the this peak will less than the 3000 means this is for allophatic reason. Okay. So these are the characteristic peak we'll find out in IR. So these are the applications of IR spectroscopy you can use only for the organic compound very easily. I know sometimes it will use for inorganic compound as well, but clear idea you will get for organic compound. Then the different structure determination, whether this is acid or ester, you can identify using IR. Then the functional group, then progress of reaction means we can monitor like TLC, we can monitor through IR. Then types of hydrogen bonding also we can distinguish. Ketoenol tautomerism means whether there is ketone group or alcohol group, that also we can find out. Cis trans isomerism, that we can distinguish, and presence of water sample or water, if there is moisture you will find out the peak in the IRS. Okay, these are the few limitations of IR, because using this IR we cannot calculate the molecular weight of compound. Actually that is not their application, but these are the few limitations you can see it. And rather than limitations, the very good applications of IR spectroscopy are there, right? The sample cells are made of halogen salts. Actually, this is the old information, but nowadays we can keep sample directly on the sample holder. No need to use sample cells. Okay, so there is no interruption of moisture in the IR spectroscopy. That is called as ITR, uh, IR spectrophotometer. It have lot of cost, but it will give very nice results, right? And the very important limitation is we cannot analyze gas samples in the IR spectroscopy, okay, due to the lack of sensitivity. This is the very important. Finally, I would like to thanks our college who has given me the opportunity. Especially thanks to principal ma'am and all of you. Right? If you have any questions, write me an email. You will get surely the reply. Okay. Thank you very much.